Hello, welcome. Let's try to solve another Leetcode problem 42, trapping rainwater. So we are giving n negative integers representing an elevation map where the width of each bar is 1. So as we can see from here, the width is going to be 1, and we're going to compute how much water it can trap after raining. So let's just try to understand from here. So let's just check the drawing. As we can see, this is a 1 unit of water because the width is 1. This is another unit, 2. So this is another unit, another 2. It's going to be 4. This is 5, and this is going to be 6. But how should we know exactly how much water it can trap? So I think for this problem, the easiest way is going to be by using a prefix and a suffix. So this means for each of the position. So for example, the first position at the left side, is that possible to trap any kind of water? No, it is not possible, because if there's any water, because at its right side there's nothing, definitely there will be no water. What about at the left side, this one? Can it trap any water? No, because at the right side it is nothing, it cannot trap any water. So this means at the ends, at the left and at the ends of the right, it can never trap any water. So we just need to analyze something in between the left side and the right side. So this is going to be the left side, and this is going to be the right side. Yeah. But for any unit, for example, this one, at this place, if we know from the left side what is going to be the maximum height. So for example, at the left side, the maximum height is going to be 2, because this place is going to be the maximum. At the right side, the maximum place is going to be 3, because at this bar is 3. Yeah. So this means at this position, then definitely the minimum height is going to be 2. The left and the right is going to be 2. And then we're going to use this number 2 minus the height. Currently this height is 0. Yeah, so 2 minus 0, it is 2. Yeah, so this means at this position, definitely we can trap 2 units of water. Yeah, according to this way, definitely we can solve it by using the prefix and suffix. Prefix sum and suffix sum to solve the problem. Yeah, and because at each unit it is 1, but there can be something. So for example, this is something like concrete. Yeah, and this is the evaluation map. So the concrete can never trap any water. So this means that here can trap 2 units of water. Yeah, this means from here we can trap 2 units of water. We just check at the left side what is going to be the maximum height. At its right side, what is going to be the maximum height. If it is 2 minus, is there any solid or any concrete? It's just minus, because there's no solid stuff, no concrete, so just use 2 minus 0. Yeah. And same idea, for example, at this place, can we trap any water? At the left side it is 2, right? At the right side the maximum height is 2, because this bar, we just need to check the bar, this bar is 2. So the maximum from the left and the right, it is 2. So what is the height? It is 3. Yeah. Can we use 2 minus 3? It is negative 1. Definitely we cannot use negative 1. If it is negative 1, so definitely we're going to use 0. So this means at this position we cannot trap any water. It's going to be 0. So if it is a negative value, so definitely it's going to be 0. Yeah. So this is going to be the second case. We just need to analyze the first case here and the second case here, and then we can solve the problem. Yeah. So let's just copy the array. We're going to prepare a left max array and right max array. So we're going to copy the height array. We just make 2 copies, and we're going to prepare n going to be length of the array. Yeah. Now we're going to prepare the left max. So for I in range, we're going to start from the second value to n. So the left max I going to equal to the maximum of left max I with left max I minus 1. Yeah. And similarly, we can prepare the right max, it means the suffix sum. Yeah. So we're gonna start it from n minus 2. So this means we're gonna start from this position here. Yeah, we're gonna start from this position here because here it is possible. So we're gonna prepare the right max. -1 and -1. So the right max I gonna equal to the maximum of right max I with right max I plus 1. Yeah, so let's just print out the left and the right to check if everything is okay. Currently I'm going to return a random value which is going to be 0. Yeah, as we can see from the array, so yeah, as we can see from the array, this is going to be the left max. So here is a 0, 1, 1, 2, it is a 3, it is increasing, and this is going to be from the right side. This is going to be 1, 2, and it is increasing from the right to the left side. So this means everything going to be okay. Yeah. Now what we need to do, we just need to get the final result. Yeah. So we're going to check it from 1 to n minus 1 and gonna plus equal to the minimum of the left max I minus 1 with the right max I plus 1 and minus the height, which is going to be height I. Yeah, but as we checked before, it can be a negative value. So for example, this one, 2 minus 3 is going to be a -1, but it can never have a negative value, otherwise it's going to be wrong. So this means we need a final check. So the final check going to be, we're going to use our max. If it is a negative value, so we're going to choose 0 instead of a negative value. And this is often used in algorithms for a lot of algorithm problems, because in real cases it can never be a negative value. I think now it should be okay. Now let me just return the final result. Yeah, let me just run it to have a check. As you can see, it works. Now let me just submit it to check if it can pass for all testing cases. Yeah, as we can see, it passed for all testing cases, and I think the speed is okay because the time complexity is going to be n equals 2 times 10 to the power 4. So this means it is okay, and it is also easy to analyze the problem. We're going to just use the prefix sum and suffix sum, and for any position we just check from the left side. So for example, for any position, for this position, we're going to check its left side, what's going to be the maximum height, it is 2, and from the right side, what's going to be the maximum height, it is 2. So definitely it means it's not possible to trap any water, but in this position, at the left side it is 2, at the right side the maximum height is 3. So this means we can trap 2 units of water at this position. Yeah. I think that's all about it. Thanks for watching. See you next time.